On number 4, you're to find the amplitude of the function and then use the language of transformations to relate the function to the graph of y equals sine x. Well, should be at this point in the semester pretty straightforward because the only transformations involved are from the negative 7 over 4 coefficient. And the first thing it asks us to do is to find the amplitude, and the amplitude sets the height and the depth of our peaks and valleys of these sinusoidal graphs, but it's the absolute value. You don't count the sign when you record the amplitude. So you write it as the absolute value of negative 7/4, which is 7/4. That's our amplitude. So then we're going to get to our transformation language, and the negative sign, because it's on the outside of the function, creates a vertical reflection over the x-axis. And the only other transformation involved here is the fact that the amplitude is there, the 7/4 itself being the multiplier it's been throughout our discussion of function transformations. Because 7/4 is greater than 1, this is a vertical stretch. And we've been using this language throughout the semester as well, but now you really want to emphasize what we're about to write. This is a vertical stretch away from the x-axis. Because of the structure of these graphs, this becomes more important to think of it this way. And I might want to actually write the x before the axis. And we'll see that in some of the ones we actually graph. On to number 10. Number 10 says, find the period of the function and use the language of transformations to relate the function to the graph of y equals cosine x. And again, we don't have a whole lot going on in this function. The only transformation is the negative 0.4, and I see that I left the x out, so let me fix that right quick. Make this a little smaller so I can squeeze it in, since I did not leave enough room here. So this is negative 0.4x here. But we need to address the negative 0.4 in terms of our transformation. But the first thing this one asks us to do is the period, where the last one asks us to do the amplitude first. And remember that the period of a sine or cosine graph is equal to 2 pi, which is the period of the parent, divided by the absolute value of b. And b is the coefficient on the inside of these graphs. So our period here is going to be 2 pi divided by 0.4. Well, since this is a no calculator problem, we're going to rewrite 0.4 as 4/10 reduced to 2/5. So that is 2 pi divided by 2/5. And this becomes a super easy problem when you recognize this way of approaching it. 2 pi over 1. Now we're going to change the division problem into a multiplication by the reciprocal, and the 2's cancel, and we discover that our period here is 5 pi. So it's not surprising that our period is larger than the parent, because we know that the 0.4 inside, because it's less than 1, so let's acknowledge those transformations now. The negative on the inside is going to horizontally reflect over the y-axis. And the 4/10 or 2/5 on the inside, because it's smaller than 1, is going to horizontally, and I'm going to abbreviate because I've written too big and running out of room, horizontally shrink by 2, or no, I'm sorry, I just said shrink. try that again. Horizontally stretch the graph by the reciprocal of 2/5, 5/2 or 2.5. And again, we will see this in action on a couple of these that we're about to graph. So let's move on to number 16. And we are to find the amplitude, period, and the frequency of the function and use this to graph this function. All right, now I put some steps in your packet and I strongly recommend that you follow them. But let's follow the directions first here. So let's do our amplitude, which in this case is the absolute value of -4, so our amplitude is 4. The period is going to be, again, similar to the one we did a minute ago. So let me sneak over here to the side and see if I can squeeze this in. The period is equal to 2 pi divided by 2/3, which would be the same thing as 2 pi times 3/2, so it's going to give us 3 pi as our period. And the frequency, which I sort of de-emphasize, but it will come back if I don't forget to say this, and if I forget to say it in the video, ask me about it when you get to it. The frequency just tells you how many times, how many actual cycles, or how much of the period one cycle will take up. That's what it is, because it's just the reciprocal of the period. So this is 1/3 pi. So we've met the requirement of the problem by listing those 3 items, and as I said in the packet, I included some recommendations for drawing the parent graph first. So let's do that, and then we'll switch back to our purple color to graph the function itself. The parent of this graph obviously is sine, and remember, sine goes through the origin, and then at pi/2 sine is 1, and then at pi sine is 0 again, and then at 3 pi/2 sine is -1, and then at 2 pi sine is 0 again. Then you want to trace that periodic little curve there, and there's one period of the sine graph. Well, now we want to take that and apply these transformations that we have in this function, and there are no horizontal or vertical shifts, so this is going to be simply a stretch on the inside and the outside. There's kind of a twist to the way you should approach these that makes graphing trig functions really simple. Some people find it difficult, and I think some teachers make it complicated, but I think this strategy will help you if you follow it. Alright, so we're going to deal with the fact that the period is 3 pi first. Well, as we can see from our parent graph, the period of it is 2 pi. Well, what this tells me, because remember, points that are on the x-axis are going to be pulled relative to their zeros, but this one is going to get stretched horizontally, but it won't get stretched away from 0, 0. So 0, 0 is a sort of a fixed point in this picture. So we're going to move out to 3 pi, and we know that our graph is going to stop at 3 pi. Well, this is where you need to start paying attention to the structure of the graph itself, of the sine graph, and you notice that the way this thing is shaped, that at its center it crosses the x-axis again. So in one period it crosses the x-axis at both ends and once in the center. Well, now our center is halfway to 3 pi, which would be at 3 pi/2. So this is where our 0 is now. So we've got our 3 zeros of one period of this new graph plotted. So now we need to get the points in between. Well, if you notice that between the zeros here of the original function, there is a peak or a dip at the halfway point in between. So now we want the halfway point of 3 pi/2, and half of 3 pi/2 would be 3 pi/4. 3 pi/4. So we're going to go to where, let's see here, on here a fourth would be at 2. So this is, I'm going to go halfway between, and honestly, here's the easiest way to do this. Let me undo that mark. Here's the easiest way to do this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes between 0, 0 and our first 0 on the inside. So that means we need to go 6 to the halfway mark, which would be here. And that's where 3/4 is. Well, now the only thing we need to do is to figure out how far up to go, because this didn't have a negative coefficient, so it's going to follow. Oh wait, sorry, it did. I lied. It has a negative coefficient, so this one's actually going to be upside down. So we're going to go, instead of going up 1, we're going to go down 4 and plot that point. And then we're going to come over to the other side. In fact, let's go ahead and draw that piece of this. So let's see if I can do this. Moment of truth here on my tablet. Okay, not bad. That's the left half of the period, the one period of our graph. And then we're going to do the same thing here. So since the center point a minute ago, as we talked about, was 6 steps away from either endpoint here, we're going to go 6 boxes to the right. And this is the center point for this side. So we're going to go up again 4, and on my scale I have here, 2 boxes is 1 step, so I'm going to go up 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8 puts me there. So now I'm ready to draw this side. So I come up, hit that point, and my board quit cooperating with me here. Hang on, and I did it again. Oh, that's not too bad. We'll take that. All right, a little messy, but you get the idea. Let me see if I can undo, make that a little smoother. Because this is sort of parabolic, but these are not really parabolas. And there's the other side of that graph. So then you would continue that pattern on out. Now in the steps in your packet, I tell you that once you draw one period, just use your pattern. Well, the trick here is that the zeros are 12 boxes apart, and obviously we don't have 12 boxes on the right side over here, but I can see if I have a center point, which would be 6 boxes to the right, and then down 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 8 puts me right at the edge of my picture. Well, that works perfectly, because then I can just extend that curve on out, and it's just like I've been trying to convince you all semester. When you draw a graph, you should fill the available space with the graph that you are producing. So now, sorry, we're going to slide over here to the other side and do the same thing. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we don't have enough to do another complete half cycle on this side, but we'll go to the left 6 and up 8. And if I did not screw that up, there's the point. So now I'm going to smooth that out and continue the pattern to get a sketch. And that last little bit didn't look very good. Let me see if I can make that smooth. And that's not too bad. So there is our graph. One more for this video, number 18. A similar thing, but this has got a slightly different set of directions. We're to graph one period of the function using your understanding of function transformations, not your calculator. And again, I would recommend on this one that you start by graphing the parent. So let's start with the parent, and in this case we're still dealing with sine. So we'll plot the origin, and then the scale is different here because of the fact that our I'm not sure why I did the scale different on this one, to be honest with you. But anyway, I think I was reusing a graph from another problem. But we're going to go to where our next 0 would be for sine, and that's the first one's at 0, the second one is at pi, and we have to draw one period, so we just need to get one peak and one valley, and we're done. And then the other one will be at 2 pi, so we can't go in this direction. So let's slide to the opposite end down here and see if we can get the rest of it. So I'm going to go, I didn't give myself enough room, did I? Okay, we'll figure that out in just a second. Alright, so now we're going to go halfway in between, but we have an amplitude of 2.5 that we're going to contend with here. Oh wait, I forgot I was drawing the parent. Sorry, time out. At least I caught it this time, and you don't have to point it out to me. Okay, so halfway between 0 and pi would be pi halves. So I'm going to go up 1 and plot that tiny little Looks really small by comparison here. And that's the thing about these graphs. They're going to look really, you have to be really careful about what your viewing window is if you're looking at it on your calculator or if you're looking at one in the book, just because you can see what a difference it makes in the picture. All right, so then again, if you get the pattern here, this was 8 boxes and up 2. So now I'm going to go 8 boxes to the right and down 2, which matches perfectly with our understanding from the unit circle that at 3 pi over 2 sine is -1. So then I can just sweep this up and it's going to run off the window here. And that's not quite a period of the sine graph, but that's enough to get us going. All right, well, the only difference between this graph and our graph is that we have an amplitude of 2.5. So we're going to take care of that by simply keeping the same zeros. And since we technically didn't get an actual period here, we might back up a little bit and extend the pattern back to the left. So I don't have another 0 there to trace. So now I'm going to go where this was at 1, I'm going to go up 2.5. So that would be 2, 4, 5 boxes, since my scale is 1 vertically is 2 boxes. And then I'm going to draw that peak. If I can get my pen and my board to, there we go. All right, and then I'm going to draw the dip over here. So where this one dipped out at -1, the parent, I'm going to go down to 5 boxes down, which would be decimal equivalent of 2.5, and I'm going to make it come out and go down, which would look something like that. And that would be one period right there, kind of running off the edge of my graph paper. And that's the end of our video.